All right, guys, so we are on 1-6, and it is all transformations. You guys did transformations a little bit in the past, right? Yeah, I hope we get through 1-6 today. We're probably not going to get much farther. Okay, so remember, I'm just going to do a little reminder for you guys. We had f of, we can say y equals f of x. And then I did this the other day where I did like a minus c and a plus d at the end. And then like an a and a b at the beginning. Could you tell me if I'm like adding or subtracting something from the end? How does that move my graph? Down or up? Very good. Moves it up or down. Again, we kind of had these notes a little bit earlier, but I'm just reminding us. So if I'm adding or subtracting from the end, it's up or down. What if I'm adding or subtracting inside with the x? How does that move it? Good, it moves it left or right, and it's opposite of what you think. So I like to write on this one, okay, well, it's opposite of what I think. So left should be negative, but it's actually positive, and right should be positive, but it's actually negative. Another good thing to remind ourselves while I'm here with my different colored sign pencil is for up and down. Up is what you normally think it should be, and down is not what you think it should be. No, that's a lie. They're both what you think. Down is negative, sorry. Sometimes I say things, I'm like, that is not what I thought in my brain. Okay, in the very front with my A, that's what like does vertical changes to my graph. It changes my Y's. So I'm gonna write vertical change. It makes it skinny or fat is kind of like what I generally tend to say. And what you're doing is you're doing it to the Y. So if I have like if I have like a 2 out here, I'm multiplying my Y by 2. I'm doing whatever that number is to my 2. If it's a 1/2 out there, I'm doing 1/2 times my Y's, all my Y's. And then if it's negative, then that means that we flip. And we flip over the X axis. What I did last time was I skipped the number in front of X because I was like, yeah, we're just not going to worry about that right now. What I want to say here is if we have something in front of the X, that does horizontal changes and it changes my X value. Yeah, someone's gonna party. Must be nice. If it's negative, it's going to flip as well, but it's not going to flip over the x-axis. It's going to flip over the y-axis. As you're doing this, make sure we have our masks on our faces. Make sure your nose is covered, not x-axis, y-axis. Good. Okay. The B is a little bit more uncommon. We're not going to deal with that much, especially at this level of math. It's just not that deep. I would much rather you have an understanding of the A and the C and the D. If those are good, then you're going to be fine. All right, what we're going to do is we're essentially taking this graph right here, and we're going to do all of the transformations. All of the transformations. So like this one graph is going to be used for all of these numbers. Same thing for number 2. We're going to use one graph for all of these transformations. So we're just going to see what we can get through. Half of the battle might be just thinking about what all the points are. So I'm going to copy and paste this graph since I have that ability for each one, so you can see what the original was and what it looks like. But you're just going to draw a new graph for each one, okay? So I'll show you what I'm thinking for this. That's not good at all. Let's try this. Okay, I'm going to copy that and put it over here. No, no. There we go. Guys, I barely understand notability. It's like year 5, and I still don't really, 3. I still don't really know what's going on. All right, so this is your original graph, and I'm doing 2 f of x. That is in front of my f of x. That's the same thing as my a. So that means I'm changing all my y's. I'm going to multiply all my y's by 2. Yes, Grace? You're going to draw a brand new graph for every problem. What I'm going to do is lay the new graph on top of the old one so you can see how they relate to each other. Mm-hmm. So what we're doing is we're going to do, it's going to be a vertical stretch of 2, and I'm going to physically multiply my y's by 2. In order to achieve that vertical stretch, you're just going to multiply all the y's by 2. And actually, we probably should have done this first. Let's go over to the graph and let's label all the points so I don't have to think about it each time. Let's label all the important points. So like I see that like this first one's at -2, -3. So I'm going to write that next to it just so I don't have to think next time. It's just already there and I know I can easily multiply. I've got a point right here. I already labeled that -2, 3. It looks like there's a point here, which is -1, 0. I've got a point over here, which is 0, 1. This point is 1, 0. Everyone okay with how I'm getting these points, right? The next one's 2, -2. Then I have 3, 0. And then I have 4, 2. What you are going to do is we're going to multiply all of our y's by 2, and we're essentially drawing a brand new graph. So I'm going to draw what I want you to show, and then I'm going to put them on top of each other because I think that's helpful. So you have a brand new graph, and we're going to redraw all of these points. So like the first one was -2, -3. Well, if I'm multiplying my y by 2, what's my new y? -6. You keep your x the same, -2 stays the same, but now I'm going to go down to -6 instead. So I'm going over 2 and I'm going down 1, 2, 3, 4, 5, 6. That's like down here.
Also, I'm sorry, you had asked about the points. How did we get 4, 0 for that first point, like off to the
No, that's
axis?
1, 0. It's just sloppy.
Oh, okay.
Yeah, 1, comma.
Never mind.
No, it's okay. It just was messy.
Okay, thank you.
All right, what about when I have -1, 0 and I multiply my y by 2? It's the same. So all of my 0 y's stay the same. They're all still on the axis. So I can keep that -1, 0 there, and that 1, 0 there, and that 3, 0 there. My 0, 1, I'm going to multiply that 1 by 2. So instead of being at 1, it's going to be up at 2. My 2, -2 goes down to -4. And then my 4, 2 goes up to 4. So 4, 4. Um, 4, 4. I drew it twice just for effect. Do you see how the one that was on the original graph is like stretched out a little bit from its original graph? Sometimes I think it's helpful to see it on the normal graph just so you can make assumptions as we go along. And then you have your graph. Any questions? All we did was multiply my y's by 2. Ready? Let's do another one. This next one says, oh, sorry, are we actually ready? Yeah, okay. The next one says y equals f of x plus 1. What does that 1 do to my graph? Moves it to the left. So I'm going to move all my points to the left. Left, 1. Now, sometimes kids are like, oh, I add 1 to it. I just think move it to the left. So if I was at -2, -3, I'm going to move it to the left 1, which is your x. So move it to -3, 3. Bless you. So you can think about minusing 1 from all of your x's. You want me to talk as I'm doing it, or are you guys doing okay? Talk? Okay, so I minus 1 from my -2 to get -3. So my first point was at -3, -3. My second point's at negative 1, 0, so I moved that to the left one, so now I'm at negative 2, 0. Third point was at 0, 1, so I moved it to the left one, so now I'm at negative 1, positive 1. Fourth point was at 1, 0, so I move it to the left one, I'm now at 0, 0. 2, negative 2 was my fifth point, I move it to the left one, so now I'm at 1, negative 2. It was 3, 0, now it's 2, 0, and then it was 4, 2, and now it's 3, 2. Something like this. If I were to put it on the existing graph, I would have just moved everything to the left. So sometimes I think it's easier because I could just literally move all of these over one and call it a day. See how it shifted? Any questions? You did okay? All right, when you're done, flip it. I'll keep it up so you can still see letter B if you're still working on letter B. But letter C says y equals negative f of x. What is that negative gonna do? Flips over my x-axis, so everything just flips. Essentially all my y values switch. If it was negative 2, negative 3, it's now negative 2, positive 3. It's on the other side of the axis. You can think about negative 1 times all your y values if that makes you happier. Mm-hmm. So I've got negative 2, positive 3. I have negative 1, 0. Oh, that stays the same. All my zeros stay the same. So negative 1, 0, 1, 0, and 3, 0 all stay the same. Then 0, 1 goes down to 0, negative 1. 2, negative 2 becomes 2, positive 2. And then 4, 2 becomes 4, negative 2. Negative y. What I might encourage you to do after you do this one, maybe we should redraw the first picture on the second page. So I'm going to zoom in on this guy. I want you to draw an original on the side somewhere so that you're able to not have to flip back and forth. Does that make sense? I mean, unless is it easy to flip back and forth? Oh, yeah. Oh, if you have it, yeah, if you just keep it open, you could do that. If it makes you happy, though, take a minute and recopy it down. On my hand, I'm going to copy and paste it, I think. All right, and again, if I were to draw the first one back on the original graph, everything would be the same on the poles, and then everything would be flipped across. So it looks like a cool little curvy thing going on. All right. Next one, we've got absolute value of f of x. So I'm doing the absolute value of f of x. What does absolute value do again? Makes what positive? And what's inside of it right now? I think it's, oh, that's f. I kind of threw over it. My whole function's inside of it. So that means That's the same thing as your y's. If it's an absolute value on the outside of your function, then there are no negative y's. You can plug in whatever negative number you want, but there are no negative y's. So all of your y's need to go positive. You don't change the actual value, but if it's on the negative side, you just flip it to the other side. If I'm looking at the original one, everything that's above it is cool. Everything that's below has to flip. So this point has a negative y, so I'm going to make it become positive. So it's -2, -3. So instead of -3, I'm going to have -2, +3. And then the points on the axes are fine, and that 0, 1 is fine, but then the next point here, that can't be negative, so that has to get flipped up. So instead of +2, -2, it'd be +2, +2. It looks something like this. All right, I'm gonna be completely transparent with you. I didn't research well enough on what happens if only the x is absolute value, so we're just gonna skip that for right now. Just skip that letter. I think I know what it means, but I don't want to have to come in on Monday and be like, all right, everything I said was wrong. So I'm just not going to say anything. And we will, I think, move on to the next picture. Is that right? Oh, yeah. Yep, so skip letter E, we'll come back. Skip. Don't like exit it out, just like don't write anything. Ooh, Ava. There's always one kid when I'm like, we're not going to do this. And then they get like a giant Sharpie and they start like exiting out. I'm like, okay, calm down. Calm down. All right, we're gonna do another one. Do you want me to let you try this for a little bit on your own and then jump back in together? Nope, you want me to hold your hand? Yeah. Okay, we'll hold our hands like a kindergarten chain down the hallway. All right, we're gonna chain our hands together. All right, let's see what's going on here. Okay, so I've got -x and a +2. Oh yeah, that first one looks hard, doesn't it? We are gonna skip letter D though, because I already know I'm not gonna do that one. We can do this first one though. What did I tell you happens when we have a negative with our x? Flips over which axis? The y-axis. So essentially it flips like this way. Flip over x-axis. Y-axis. Thank you guys. And then we move up 2. What I would argue is that we should do everything to x and then we'll do anything to y. So we're going to flip over the y-axis and then we're going to add 2 to it. You can do this one of 2 ways. Sometimes I like to sketch the first one and then just move all those pieces up. If you'd rather not do that, then we'd have to flip and add at the same time. Let's label these points first so I know exactly what I'm talking about. It looks like I've got, this one's -1, 0. That does not pop as much as I want it to. That's -1, 0, -2, 1, -3, 0. Whoa. Oh my God, crazy. And then it looks like this is -0, -2. And then 1, 0. And then 2, 1. And then 3, 1. Okay, if we're flipping over the x-axis, you can think of that as we're changing all of our, we're multiplying all of our x's by -1. So if I'm flipping this -3, 0 to the other side, it's going to become +3, 0. So it's going to go over there. So I'm making all my x's change their sign. So let's draw that one at a time. Go ahead. Okay. So I now have positive 3, 0. And then I'm doing negative 2, 1 becomes positive 2, 1. If you want to, Elle, you can move it and then move all the points up 1. I can't keep all that in my head, so I'm going to do 2 graphs. Negative 1, 0 becomes 1, 0. Negative 0, negative 2 stays the same. One becomes negative 1. Negative 2, 1. And then 3, 1. It almost looks the same. What's the 1 points that are different? The first and the last one are the ones like that look different. Other than that, it looks the exact same. And now, just as I kind of previewed, we got to move everything up 2 units. So again, I would rather like sketch this lightly or in like a color to be like, okay, well, I did my first thing. I did my negative x check. Now I'm gonna move it up 2 units. I'm gonna use a different color. You can keep 2 graphs on your picture as long as I know which one's your final one, or you can draw it and then erase the second one. This is kind of up to you. This is like my first transformation. We're not done yet. Now we have to move everything.
Wait, what is? Sorry, I'm sorry, I didn't mean to interrupt. Is this the flipping like over the y axis?
We did our flip over the y, and now I'm gonna move everything up 2.
What exactly changed?
These last 2 points. All the other points are basically.
Oh, okay,
so
okay.
It doesn't look as big of a change as what it should be, but we do see the first and the last points are different, so that helps us keep it straight.
Is it because like it just like turned over or something? Like if it was facing that way, you just like turned it. Like if it was facing up, you turned it back. No, that's still not a good description.
It's now facing right.
Okay, that makes sense.
Right?
I think. Okay, thank you.
It's the y's, yes. We're going to move all of our y's up 2, or you're going to add 2 to all of your y's. So if I add 2 to this y, it goes up here. 1, 2. 1, 2. Oh, come back. Where are you going? Well, that looks really messy, but that's what it is. All right, so we reflected it over the y-axis, and then we added 2 to all my y's. And that's it. That red one that I graphed is the final graph. We okay with that? The purple is just when I did f to the f of negative x, where I just flipped across the axis. The farthest left point, -3, 1. All right. Let's jump to C because that's more similar to what we just did. So let's just stay on that train. Letter C is absolute value of f of x plus 1. What does the plus 1 do? Does what, Ava? Moves it up 1. And then what does the absolute value do? Makes it positive. Good. So all my y's are positive. When I would do this, I'd probably do your positive y's first, and then I would probably move everything up. So I'm going to switch all my y's to make them positive, and then I'll shift everything up 1 unit. So what negatives do I have to worry about? -2. That's the only one. Cool. I'm sorry, guys. I got tired of it. That's the only one. So if I switch that above, I'm going to make that instead of 0, -2, 0, +2. And then I can move all my points up from there. So I might just do that one all in one step. Everything else is at 0 or above 0. So do you see how I just traced the red? That's if I only did the absolute value. The only point that needs to move is at 0, -2. But I also need to do +1. So now I'm going to take all those points and shift them up 1 unit. Again, I'm only going to have one graph this time. But I also have to see them. On A, the negative was on the inside, so that's dealing with the x's. Now I'm doing the y's because the absolute value is outside of the f of x. Good question. Yeah. Mm-hmm. Mm-hmm. Yeah.
I was just wondering, so we flip it up and you flip the 0, -2 to 0, 2, right?
Mm-hmm.
And then you just move it up 1?
Yep, and then you move that point and then every other point up 1.
Mm-hmm. Thank you.
You're welcome. All right, you okay with that one? Okay. I actually want to switch B because I don't think we did enough practice with like several transitions at once. So I want B to read this instead. Crossing out. Maybe we can do one more because I'm skipping that absolute value one. B, yeah, cross out B. I don't want to do that one.
D?
B as in box or
Box.
ball
Okay, B.
or boy.
Mm-hmm. Got it. Thank you.
No, we're writing a new one. So I want you to write a new problem for B because I want us to do several translations at the same time. Yeah, we haven't done this many yet. I think we can do one more. At 25.
Oh.
That's when the cleaning bell goes off. So I think we have time for one more, right? This one that we're doing right now. All right. So if you want me to walk with you, join your hands. Chain down the hallway. I've got a negative out front. What does that mean? Flip across what? We're going to flip the y's across the x-axis. You're flipping up and down like this. So it's going to be like negative y. You're going to make all your y's have a different sign, and you flip over x-axis. All y's change signs. See, before the negative was inside with the x, this time it's on the outside. All right, and then what do my 2 and 3 do? Right 2, down 3. Yep, I just erased B.
So we're gonna do 3 separate.
I'll probably do 2. I think I can do the flipping over the x-axis by itself, and then I think I can move all the points right 2 and down 3 at the same time. I have confidence in myself to do that. I have confidence in you to do that. Let's start by flipping. I think we should flip first before we move right and left. Okay, so flip all of them across the y-axis. All my ones on the axis are good. So negative 3, 0 is cool. Negative 1, 0 is cool. 1, 0 is cool. Everything else has to go across the x-axis. So negative 2, 1 becomes negative 2, negative 1. 0, negative 2 becomes 0, positive 2. 2, 1, and 3, 1 become negative 2, or sorry, 2, negative 1, and 3, negative 1. All right, when I flip the x's, I got something like this. Remember, we're all sketching, so it's a little bit off. We don't have any lines or grids, so you may be like closer together or farther apart, or closer together or farther apart. And then now I'm going to take all of those pink points and move them right 2 and then down 3. I'm going to do it in this, in this green. So right 2, 1, 2, down 1, 2, 3. That point just got to go here. Right 1, 2, down 1, 2, 3. My scale is definitely off. It looks kind of funny, but oh well.
What's happening with that, with the arrow?
That's just me showing this point went here.
It like jumped?
Well, it translated by going down 2 and right 3. Sorry, right 2, down 3.
I'm so sorry. Why does it start so over though?
Because
because it went.
I just flipped over the x-axis in the pink graph, and then now I'm moving them all right 2 and then down 3.
Okay, you're doing 2 steps at once.
I am.
Okay, thank you.
All right, guys, and this is what mine looks like approximately, the green graph. Let me stop recording so that no one has to watch